Well, okay, so here we are. We knew it was going to come to this at some point, didn't we? So we're here in the morning. We're reacting to our early morning videos. People are sending me requests and asking me to check things out. I'm happily obliging at this point. Well, what do? I come across this video by one Deepak Chopra. The universe is an activity in consciousness. So if you've had any familiarity with me, then there's two things you should know about me by now. The first is that I take idealism very seriously as someone who doesn't accept it can, I would say. I think it's an interesting view. There are reasons for thinking it's a possibility. I've never been moved towards that direction. But at the same time, I know serious people who are, and I think about these issues all the time. So Deepak Chopra is kind of a well-known defender of some version of idealism. I'm not a super expert in Eastern traditions, but I think there's some similarity to Advaita Vedanta. I don't know how to say these words, but anyway, I think there's some tradition from which his ideas stem. I also think that he does a lot of self-help stuff, which is questionable, and that I think maybe one should be cautious about, because I don't believe in manifestation or any of these other kinds of things that people talk about. So, having said all of that, I find Chopra's views a bit of a mixed bag, because while I want to take the idealism stuff seriously, I don't want to take the self-help stuff very seriously. Having said that, here is this video. The universe is an activity in consciousness. Which made me almost want to watch it, because my understanding of idealism was that the universe is consciousness, not an activity in consciousness. So I was wondering if he was going to say anything interesting, and I figured we may as well check it out. So I don't know what this comes from, something called the Chopra. Well, I'm not in this cult. I don't know about these things. I know he tends to talk slowly and with a certain tone of voice that I find very irritating. I mean, his calm, like, spiritual voice. Anyway, enough of me flapping. I am curious to see what he's going to say. So I'm going to steal, what did they say? Gird my loins and steal my steely eyes. I don't know what I'm saying. Let's just listen. Oh.
So this afternoon we have now 2 hours. We'll take a 5-minute breathing break in between. But we're going to go very deeply into understanding what I can only call reality. Okay? So I want to show you this month the book You Are the Universe, which is my last book with the quantum physicist, cosmologist.
By the way, I haven't read this book. So someone's already going to come at me. Why aren't you reading these books? I just saw this video. Thought I'd watch it. That's why.
That was featured on PBS. I don't know if anyone saw that. You saw some of you. And it's going to be showing again. There might be a 10-part series on that later from Amazon or one of the entertainment companies. So I want to show you a 3-minute trailer of that, and then we'll go with our discussion.
3-minute trailer.
I'm Dr. Deepak Chopra. In the next 60 minutes, I hope we can all together, with a little help and insight from me, help solve the mystery of our existence. I was traveling through the country, and one of the places that was part of my tour was Los Angeles. I was picked up at the airport by my son Gautam and my grandson Krishu as we call him, who was then 5 years old. He's a very smart little mind, a very smart little fellow. So as we got out of the airport, he looks at me and he says, Dada. Dada is the Indian word for grandfather on the father's side. He said, Dada, what is dark energy? Interesting question to come from a 5-year-old. And I said to him, what do you know about dark energy? And he said, it flows through the night sky. Very poetic, very beautiful. I said, what else do you know about it? He said, it's 70% of the universe. I'm thinking to myself, how does he know all this? We get out of the airport and we're driving in the car. We're driving in Santa Monica. I roll down the window and we can smell the ocean, we can see the ocean. He looks at me again, he says, how did they make that? I said, make what? He said, how did they make the ocean? I said, who make the ocean? And he said, they. I said, that's not a precise question. You have to tell me what you mean by they. And so I can see him thinking for a bit. And he reframed the question. He said, how did the ocean get made? So I said, the ocean got made the same way as the earth got made. A giant star exploded, and that was the solar system. We're a planet amongst many. The ocean is part of the elements of this planet. And then I kind of turned to him and I said, do you know how many planets there are in the solar system? And he said, well, if you count Pluto, there are 9. But if you don't count Pluto, because some people don't think Pluto is a planet, then there are 8. I said, and where did the solar system come from? He said, the galaxy. I said, where did the galaxy come from? He said, the universe. And I asked him, I said, and where did the universe come from? And without batting an eyelid, he said, from another dimension. So, I'm Indian. I'm thinking, who's this kid? We believe in reincarnation and all that. So I'm thinking to myself, Galileo, Copernicus, maybe even Einstein. I said, Krishu, how do you know all this? He said, it's on my Pokemon.
Wait, what? That was it? Okay.
So that should begin our conversation. If you go on Google or Wikipedia or wherever on the internet, and you look at what are the open questions in science. Open means science at the moment has no answer. When you talk to scientists, they say, yeah, we don't know, but at some point we'll know. And there are about 125 open questions in science today. The list was first published in Science magazine in the year 2006. So we are now in 2017.
2006. Okay.
In the ensuing 11 years, nothing has changed. We still have the same 150 or so open questions in science. But we want to talk today only about 2. The first open question in science is, what is the universe made of? The second open question in science is, what's the biological basis of consciousness? So let's just talk about those 2 questions today, this afternoon. What's the universe made of? So I'm going to give you the current science and what everybody says. People like Stephen Hawking and Brian Cox and Lawrence Krauss and all the big guys, they win Nobel Prizes and they work at CERN and they do science and good science. And science is based on three principles. All science is based on 3 principles. First, scientists come up with a theory. These days, most theories about physical reality are...
That's first. Wow, okay. Scientists come up with a theory. First. Oh, this is going to be a rough ride. That's not how it works, by the way. Yeah, we were just talking about this the other day. I remember. So I teach this class with Tony Rowe, the neuroscientist, and he always tells this famous story about how he was a young, either postdoc or grad student. And he was talking with the guy who he was working with, his mentor at the time, a well-respected senior scientist. And some younger kid was talking about different theories of something or another. And the senior scientist said, "You're too young for theory," indicating that you should learn techniques. You should learn how to interpret data. You should learn how to design experiments with as few confounds that ask simple questions so that you can get a direct answer from the data. So all of that has to do, so, maybe it's naive to say there's no theoretical background in the scientist's mind as they're doing these things, but I don't think they start with a theory, dude. Okay, anyway, so
Mathematical theories. So
hold on.
most theories about physical reality are mathematical theories. So mathematics is the basis of all physics. And there's quantum mechanics, which is very mathematical, and there's regular physics, and there's chemistry, biology.
Yeah, maybe this is the problem with taking physics as your main idea. But even like Newton didn't start with a theory, he started with data. Observation. Okay, anyway.
All these different disciplines, but most theories of physical reality are based on math. So scientists first come up with theories. They publish them. These days, actually on the internet, everybody has open access. Then they see if other people agree with their theories. So theory is the first thing. The second thing is observation. And so this observation these days, especially when it comes to the universe, is through big telescopes that are out there in the sky, in space. You've heard of these telescopes, Hubble telescope, James Watson telescope, etc. So that's how they look at the big picture. And then they also look at the micro nature of the universe, particles, subatomic particles, and that they do through very sophisticated technology. At CERN is the biggest place in the world, Switzerland. Next to Geneva, they have something called the Hadron Collider, where they smash particles into smaller particles into smaller particles, again, to discover the nature of reality, both at the big level and at the microscopic level. So theory is first, observation is second, and observation leads to new experiments that lead to new observations. That's the loop. Theory, observation, experiment, observation. And if everyone kind of agrees on the theories, the experiments, and if they can repeat them, they can validate them, then they come to the conclusion that this is how it must be so. Okay, that's the scientific method, and it's very reliable. There's two things that scientists all understand. A theory must be falsifiable, which means you must be able to prove that it's wrong, and it should be subject to that, and it should be validated by others. So it's a very good methodology for understanding what we call reality.
Yeah, falsifiable in principle maybe, but I don't know. The simple idea of falsifiability is I think too simple-minded. Although obviously it is an important hook into the material world. You want to be presenting theories that in principle could be falsifiable. But I think you have to be careful with this. But anyway, okay, so very cartoon level scientific theory stuff going on. Coming from the Hasslock Chain Leckers to this is like
with that kind of experimentation, observation right now, scientists have come to the conclusion. Where's the clicker? Do you have a clicker? On the other side of the what? Yes. Okay. So with that kind of experimentation and theory and validation, can we start making sure this works? The scientists have come to the following conclusions, okay? The first is that 70% of the universe is this mysterious entity that my grandson spoke about, which is called dark energy.
Now, first of all, hold on before we get all. So I like to bring up the Sean Carroll point at this moment when people start waxing how much we don't know, to counterbalance this with how much we don't know, which isn't about the ordinary stuff around us. Well, we know quite a bit about like the way things in your room, wherever you are. If you're on the subway, if you're in a house, the stuff around you that you're interacting with, we know a lot about. What we don't know a lot about are these things, dark matter, dark energy. Sure, those things are question marks for us. But we do have, so those things don't really affect the way things move around in your house or on the streets when you are navigating the day-to-day travails of life. So, okay.
Energy. So what is dark energy? Dark energy is a mysterious force that is expanding the universe at this moment where we are faster than the speed of light. So the universe is, think of the universe as like a balloon, and the balloon is inflating. And it's inflating faster than the speed of light, which is supposedly the highest speed you can get, according to Einstein.
Huh. Is that currently still true? No, I know that inflationary theory does predict that at a certain point before the Big Bang, space kind of balloons out in this way, faster than the speed of light, maybe. But that's not. Hold on. Dark energy expansion of TL question. Really? Is this true? I did not know that. I'm gonna have to look into this. It's expanding the universe. So people are concerned about this. If the universe is expanding faster than the speed of light currently, that's interesting. I had not known that.
So, according to the same scientists, the universe began with something called a Big Bang, which incidentally was neither big nor did it bang. Okay, but out of nothing, something came into existence. It was about the size of a period at the end of a sentence, and then it rapidly expanded.
No. Come on, man. Come on, dude. No. So, first of all, the idea is that all the matter and energy in the universe was compressed into a point, which is like a mathematical point. Not the size of a period, much smaller than that. But it didn't. It's not clear that it just shows up in the theory. Huh, I see what he's saying, though. Okay.
Inflation, it tripled in size every billionth of a billionth of a billionth of a billionth of a second till it became the size of a football. And then the inflation slowed down. We don't know why, but continued and still is continuing. And the universe, from where we are, the cosmic horizon, which is the farthest edge of the universe, is 47 billion light years from where we are. 47 billion light years. And what is expanding is the space between galaxies. So just to give you a visual of this, think of the universe as like a big balloon and think of all the galaxies as if you think of the Earth like a big balloon, then you think of all the continents as the galaxies, and then think of all the nations and the continents as the stars, and then think of all the stars having planets around them as the states, etc., cities. I'm just giving you a metaphor. But what is expanding is the space between galaxies. The space between galaxies is expanding faster than the speed of light. And it's a mathematical number that Einstein described. It's called the cosmological constant. So this constant, this mathematical number remains the same, but as the distance between galaxies expands because of the space expanding, then the expansion accelerates. Anyway, that's a technicality. But what is this dark energy? No one knows. Okay, the best they can say is it's the opposite of gravity. So gravity brings things together. This rips things apart. And what is ripping apart is space. That's 70% of the universe. So that leaves 30% of the universe remaining, of which 26% is another mysterious entity called dark matter. And the reason it's called dark matter is it's invisible. You can't see it. And the reason you can't see it is that it doesn't interact with light. And the reason it doesn't interact with light is it's not atomic. It's not made up of atoms. So,
well, we don't know if it's made up of atoms or if it's a new particle. This is why, for a period of time, these so-called WIMPs, these weakly interactive massive particles, were weakly interacting, were thought to maybe be a candidate for dark matter. But as far as I know, that's kind of bit the dust. But okay, so I know more about dark matter than dark energy, I think. But interesting. All right.
Your body is made up of atoms. Mostly your body is carbon, hydrogen, oxygen, nitrogen. That's about 96% of your body, and then the rest of your body is other things, sulfur, phosphorus, all the elements of the periodic table, which incidentally were manufactured in stars. So the carbon in your fingernails, the oxygen going to your brain right now, all these come from different stars. Your body is star stuff. It's the dust of stars, your physical body. But so is everything else, this table, this microphone. Anything that you can see or perceive is made up of atoms. But dark matter is not made up of atoms. and it's 26% of the universe. So what's it made of? And the answer is, of course, we don't know, because that's why it's an open question. Then why do we call it matter? If it's not visible, if it's not hard like this, why do we call matter?
It affects gravity.
Because it has the same effect as regular matter in that it produces or is responsible for most of the gravity in a galaxy. So we are a planet in the solar system. The solar system is part of a galaxy called the Milky Way galaxy. If you want, you can look at it tonight when you go out. You know, it's a huge strip of stars. The Milky Way galaxy has about 100 billion stars. Each star has its own planets. At the moment, scientists believe there are 2 trillion galaxies. 2 trillion galaxies. You can't even count that number. And there are 700 sextillion stars. Again, unfathomable. Okay, and there are trillions and trillions and trillions and trillions and trillions of uncountable planets. So, a galaxy, we are in, I said, in the Milky Way galaxy right next door to us is another galaxy called Andromeda. The next door is Virgo, on and on and on and on. These days they just give names and numbers to these galaxies when scientists discover them. But most of the gravity that holds a galaxy together is this dark matter. If it weren't for this dark matter, a galaxy would fall apart, the planets would spin off into and get lost into intergalactic space.
I mean, so first of all, I don't want to go waxing all kinds of off the beaten track here, but beaten path. What did I say? It's early, guys. So, I mean, I'm not fully against these kind of modified Newtonian dynamic approaches, which say that maybe it's Newton's theory of gravity. That's the mathematics is wrong when you get to these levels. Maybe it's not some kind of matter affecting it. Maybe it's the actual gravitational force itself is different, or whatever the explanation for why these things move in the way that they do. So certainly with our current understanding of the math, it points towards there being something affecting the gravitational force. The question is, should we modify the math? Now, I don't know, Newtonian mechanics been very well established, the Einsteinian corrections, relativity, etc. Theory that it's bloomed into. I would say we have lots of reasons, lots of evidence for thinking that those equations are on firm ground. But I will just want to point out that this is an open question. It's not known whether or not these facts point to an insufficiency in our current understanding of the physical phenomena, or whether our understanding is correct and we're finding out something new about the universe. So either way, we're finding out something new and it's exciting, but I think we should be careful that we don't know.
They would disappear. You and I would fall apart. So whatever this dark matter is, it's holding the galaxy together, and therefore the solar system, the planets, you and me.
Yeah, so this is all a bit long-winded here, but are we ever going to get to anything? Yeah.
So that's now 96% of the universe, which is unaccountable, invisible. That leaves 4% of the universe, which is made up of atoms. Of that 4% of the universe, which is made up of atoms, 99.99% is invisible interstellar dust. So we can't see that either. The visible universe with 2 trillion galaxies, 700 sextillion stars, and trillions of planets is 0.01%. So everything we can see or we can infer through all these experiments is 0.01%. The rest is unknown, possibly unknowable. If it's not atomic, your body is made of atoms, how can we ever know it? So what we have is a great mystery. 0.01% of the universe is visible. Now here's the situation. When you look at the atomic universe, I don't know how many of you are interested in science, but atoms, as you know, are made up of particles, electrons, protons, neutrons, these days, many other different kinds of particles, bosons, gluons, quarks. So when you look at these particles, you find that they have a dual nature. If you're looking for them, if you're looking at them, and if they're interacting with other particles, if they are in relationship with other particles, then they appear as material entities. They are physical entities. They have units of mass and energy. Very small, but still units of mass and energy. That's what they do at CERN, look at these subatomic particles through these big experiments. But if you're not observing an atom or a particle, or if it's not interacting with other particles, then it disappears. And what does it disappear into? It disappears into what scientists call waves. So particles are things, but waves are all over the place. And if you ask scientists, what are these waves made of? What are the waves that make physical particles? What are they made of? Because, every child wants to know, what's this made of? What is this made of? We're all curious beings. We want to know, what are the waves that make physical particles made of? Like when you see the ocean, the waves are made of water. The air waves that are carrying sound right now from me to you are made of air molecules. But what are the waves that make physical particles made of, which make atoms, which make molecules, which make everything from microphones to human bodies to crocodiles and trees? What are the waves that make physical matter? What are they made of? And the best answer you'll get are they're made of possibilities. Possibilities. A possibility is not a thing, right? It's a potential.
Oh man, a lot of assertions. Okay, so yeah. So there's some mysteries here. What's he gonna say? So suggesting that the universe is not physical in some sense, because of the duality, wave-particle duality. Okay, so we've already talked about some of this stuff and my feelings about these kind of quantum mechanic things. The assumption is that if the physical world has got to be like little billiard balls of particles, and if we find out it's not that way, then we find out the world isn't physical. So my view is that that's wrong. The physical world probably isn't made up of little balls, particles, billiard balls, corpuscles, or whatever intrinsic entities with intrinsic properties. Probably not made up out of that stuff, given what we understand. Doesn't mean it's not physical. It means we need to update our model of what the physical is to be in line with physics, as opposed to in line with ancient and medieval understandings of the world. Okay, good. So, but okay, holy moly.
So then you ask scientists, where do these possibility waves exist? Where do these possibility waves exist? And they'll tell you they exist in something called Hilbert space.
Oh.
I'm trying to simplify it as much as I can. Okay, so then you say, what is Hilbert space?
I mean, the problem with simplifying as much as you can is you make it sound ridiculous. Yeah. So, do we live in Hilbert space and infinite dimension, higher dimension, not infinite, but super high dimension space that's very different from what we think of as the three of dimensions, 4 + 1 time. Certainly, that's the theory. That's the space that our theory, quantum mechanics, postulates. Absolutely. Okay.
You find out that Hilbert is the name of a mathematician. So Hilbert space is named after Hilbert. You say, okay, I get it. What is Hilbert space? It houses the wave functions, the possibility waves. So the possibility waves exist in this space. Then you say, but where is it? And the best answer you'll get from science today is shut up and calculate.
No, the best answer you'll get is this is it, bro. You're in it. This is it. So the shut up and calculate stuff. Okay, so some people have that attitude still, I guess, but that's not. A lot of physicists are breaking out of that mold, I would say. Okay.
The science works.
It does.
But we don't know what this Hilbert space is. Obviously, it's a space in mathematical imagination. It's a theoretical space. And actually, it's not even a space, because even space-time comes from it, according to science. Bottom line, what's the universe made of? Best answer, made of nothing. Okay, this is the best answer.
Wow, that was a long way to go for a straw man. That's a long way to go for a straw man, dude. 25 minutes for a fucking one-line straw man. The universe is made of nothing. Dude, I don't want to dog on this guy. This poor guy. Okay.
that science can give you. What is the universe made of? It's made of nothing.
Sure thing, bro.
What is nothing? Don't know. But it seems like it becomes everything. Okay? So what I'm saying to you right now is not metaphysics, it's not philosophy, it's today's science. There's a big book out.
Wow. Okay. This is the type of shit that's just fucking gnarly, dude. Oh my God. I'm such an ass. I should not be laughing at this. This is serious, dude. This is serious. We shouldn't talk about science like this. We shouldn't explain all the things we don't know and then end with the conclusion, therefore, the universe is made of nothing. This is not nothing. Holy shit, dude.
Called The Universe from Nothing by Lawrence Krauss, who's a very famous physicist who studies the origins of the universe.
Oh God, not Lawrence Krauss. Okay, first of all, dude, what? No. Krauss, a universe from nothing? What he means is a universe from quantum fields. It's a very different notion of nothing. We've been over this like a trillion. When was this? Oh, 6 years ago. Okay, so maybe 6 years ago, we hadn't been over this a trillion times. 6 years ago, what is this, 2019? When was this? 2018 maybe. It doesn't say on here when this was. Does it say down here? I think the book came out in 2017, right? That he's talking about? I don't know. Anyway, okay, geez, dude. So Krauss does not think the universe came from a literal nothing, like an absence of everything. He thinks the universe came from a bunch of quantum fields where there was no things we would recognize as material, and then some fluctuations in that field, which were predicted by this math that they have, fluxed some material stuff from the field that was there. That's not from nothing in the philosophical sense. Krauss knows that. He says it in his book. He said it a million times on every podcast he's been on. I mean, I find Krauss kind of semi-annoying, but, you know, he's a physics popularizer. That's their job.
The universe is made of nothing.
Sure thing, dude. What the fuck?
That's science.
That's science.
Question, open question, one.
Open question number one. Answer, universe is made of nothing. What is consciousness? It's made of nothing. Whoa, I'm the universe. Come on, man. Spiraling out of control here.
The second question in science is, what is
Holy
the
fuck.
biological nature of consciousness?
Yes, wonderful. Good.
Why is this such a difficult question? In fact, it's called the hard problem of consciousness. Okay, again, anything I say, you can go on these days you can do a library research and find out anything. So you can go again on the internet and say hard problem of consciousness.
You can.
So what is the biological basis of consciousness? Now you can see just in the question, there's an assumption. And the assumption is consciousness is a product of biology, right? The question assumes that. When you say what is the biological basis of consciousness, the question.
When you say what is the biological basis of consciousness, maybe it does, but that's not the hard problem. The hard problem is, why is the biological basis of consciousness associated with that kind of consciousness as opposed to a different kind or none at all? So it doesn't assume that it's produced by the biology. It assumes there's a correlation between states of the brain and consciousness and asks for an explanation of those correlations. The thing that makes it hard, so boring that everyone should know, is that consciousness doesn't seem, at least at first, to be associated with any kind of function, but everything else that we're trying to explain does. That's the hard problem. Functions are the way we normally explain things, by structure and function. Consciousness at first doesn't seem to be explainable by those things, so it seems like a different kind of problem than the other ones. Maybe it is, maybe it isn't, but that's the beginning. So all of this stuff about this assuming as the brain that produces it, not true. The hard problem is there for idealists and physicalists and every view about consciousness.
In itself assumes that consciousness is produced by biology, principally the brain.
Holy shit. Okay.
So why do people believe that? Number one. Why do scientists believe that, number one? Well, if you knock somebody on the head, they lose consciousness, right?
Yeah, that's why they believe it.
If you give somebody anesthesia, every day people get anesthesia, they get operations. Apparently, they lose consciousness. If they're
I mean, this is just a simplification. No, we think this because of hundreds of years of research. And in fact, people debated this very question. If you give someone anesthesia in their foot, then they can't feel anything in their foot. But there was an open question whether there's consciousness in the foot isolated from the rest of the consciousness of the organism. This was a debate that people like spent a lot of time on in the 1800s, and that we have kind of lost interest in because we have discovered gradually that, well, you could have that same experience with stimulation of the brain and no foot at all, phantom limb pain, etc. So it's not just, oh, you knock someone on the head, they become unconscious. So there's actually some reason why, and it's a hard-won victory, actually, that we have now sort of focused on the brain. It's not just some random shit that we fucking thought of one day, dude. Oh, look, you whack them on the head and they're unconscious. All right, I'm getting way too ornery here. Let me chill out.
coma, they lose consciousness. If they're dead, certainly they're not conscious. At least that's what we think. There's no evidence that they're conscious. So most scientists believe it. I met an anesthesiologist yesterday in this course. Where is she? She's, where are you? Stand up, please. There she is. Okay, so we were talking about this yesterday very briefly. So every time she puts somebody to sleep, they lose consciousness with whatever they do. But I think what they lose is conscious experience. They don't lose consciousness, and that's a different thing. But by and large, everybody believes that the brain produces consciousness for the reasons I just told you. So how does
By and large, everyone believes the brain's correlated with consciousness, and the scientific view is that it's somehow identical or produced by a sure, okay.
do that? First of all, we know that your gallbladder produces bile, your pancreas produces pancreatic juice, your stomach produces hydrochloric acid. So biology says the brain produces consciousness. But we've been talking about consciousness since yesterday, and we are defining consciousness as that in which all experience occurs, right? That in which all perception occurs, thought occurs, sensations, images. I mentioned the acronym.
Yeah, see, is this really the way they're defining it? So there's no unconscious perception, no unconscious thought. So I guess I wouldn't say consciousness is that in which all thoughts and perceptions occur. Some thoughts and perceptions are conscious, but aren't there unconscious ones? Maybe they deny that. I don't know. Interesting.
SIFT, sensations, images, feelings, thoughts, which is what we experience all the time. So how does the brain produce that? Because all that's there in the brain is, if you look inside the brain, all there is electricity and chemicals.
Well, this guy, that's all we found so far. Yes, that's all we found so far. But as I always like to point out, we could find something new tomorrow, because in fact, the discovery that there's electricity in the brain is very recent, actually 200 years or less. So, 200, 300 years ago, there was no clue that the brain was electrical, and they were looking in there. They saw maybe some stuff that would identify as bile and chemicals of cerebral spinal fluid, etc. They had weird views about it. It's like, thought that was some kind of sacred oil or something. I was just reading about yesterday, the cerebral spinal fluid descending from the ventricles to your sacrum or something, weird theory about this stuff. So that's all well and good. But then we learned about a new force of nature, electricity, and then lo and behold, we found that very thing in the brain. So it certainly is possible, especially given all these things that we started out at the beginning saying that we don't know about physics. Certainly it's possible that we come to figure out what dark energy is, or what dark matter is, and find out that there are new elements. We have to modify our theory of physics, etc. Maybe there's some new form of energy, some new form of thing that we could measure that we haven't discovered. And then when we do discover that, when we do find that out, maybe we'll point our detectors at the brain and be like, holy shit, that was in the brain all the fucking time, this whole time, just like electricity. So of course it's different than the kind of electricity that comes from the lightning. But what we found was, wow, this thing which we just discovered, we could see it in there. So it's always possible. And it can't be ruled out, certainly given how much we don't know, that we could discover something new to measure in the brain. So yes, right now, all we find in there is electricity and chemicals. Proteins, etc. Various biological things. as well. We understand those things to the extent that we understand them. But that doesn't mean that that's all that there is there. It just means that that's all we've been able to see given what we are looking for. So we might start looking for something else if we find something else. We haven't yet. But it's important as someone interested in science to keep in mind, especially with all these open mysteries, that this could happen. And it has happened in the past, recently actually. And it changed everything when we found out that there was electrical activity in the brain. It opened up a whole new wing of the castle that we didn't know was there. So this happens in science quite often. The previous theory was that it was all hydraulics, it was fluid levels and so forth. That's what I was kind of hinting at before. Now we have a theory about electrical chemical activity. Whatever we discover next, maybe we'll have a theory in those terms. So we don't have that. We don't know what it's going to be. But I don't like this way of like putting on the blind. First of all, pointing out how much we don't know, wowing you, dazzling you with, oh my God, we don't know shit. And then putting on the blinders about what we do know and then performing the magic trick, like the ooh factor. So I'm very suspicious of the whole way of setting things up. Oh man, this is really 2 hours long. I don't know if I'm going to be able to make it through this whole thing. And this is already getting kind of long. But let's just finish this segment and then we'll see. Well, you guys let me know. Should I even finish this? I don't even know. I'm kind of getting worn down.
We see inside the brain are electrochemical activity. So let's try and take that a little bit deeper into understanding. Yesterday I spoke to you about where are you having the experience of seeing me, right? You remember? Okay, so photons are coming to your eyes, they're going into your retina, they're causing chemical reactions, that's sending an electrical impulse, it's called an action potential to your brain. In your brain there are neurochemical activities, but you don't experience any of that. What do you experience? You experience this. You experience this room, you experience these lights, you experience color, you experience shape, you experience solidity and liquidity and all kinds of sounds. It's a pretty mushy experience, the universe. Sounds and sensations and images and feelings and thoughts and tastes and smells. How do chemicals produce that? So you are scientists. How do they do that? How do chemicals produce this experience? And the best answer you'll get from scientists, we don't know, but we'll figure it out. Because,
at least they don't say shut up and calculate. And they don't say we don't know, but we'll figure it out. I think that everyone here is either sort of mystified or like check back later.
The history of science, we keep looking for answers to questions by doing experiments, but we don't know how chemicals or atoms produce experience, any experience. It doesn't matter what the experience. When you're listening to music, what's going to your brain is an electrical current. Yeah. When you're tasting a banana, what's going to your brain is an electrical current. When you have any other emotional experience, you fall in love, what's going to your brain is an electrical current. And what's happening in your brain is a chemical reaction. So how does that produce experience? And as I told you, scientists say we don't know. That's why it's called the hard problem of consciousness. That's the phrase.
That's not why it's called the hard problem, obviously. Come on, man. So otherwise it'd be the hard problem of dark matter and the hard problem of dark energy and shit. No. The hard problem is hard because it seems different than these other problems in terms of how you give the explanation. We know what it would mean to have an explanation of dark matter. It would be to give an account of how this function that we see being performed affecting gravity in the way, but not being reflective of light. How does that get done? We know what dark energy, an explanation would be. It would be an account of how something has this repulsive force. So when it comes to consciousness, the explanation needs to be something different, not about functions. It seems, at least, remember me, I'm friendly to all sorts of views, but it at least seems that it's not having anything to do with function. So instead, it seems like it has to do with this other stuff, what it's like, which doesn't seem to be obviously associated with function by evidence, by the fact that it seems like you could ask these questions about how it relates to the brain and could it be different and could you vary it but keep the function of the brain same. None of these really lead to contradictions in a way that thinking about these other things do. So that's not why it's called hard, Deepak. I think this way of putting things is very weird. Okay.
When you have time, Google it. Hard problem of consciousness.
Google it.
Now I'm talking not only about perceptual experience, I'm talking about even mental experience. So just now think of a beautiful sunset on the mountains. Do you have an experience?
No.
You can see something? Some picture?
Nope.
Well, there's no picture in your brain. All there is chemicals.
Cool.
Think of the sound of the voice of your mother. Can you hear it?
Almost. Someone who thinks of myself as aphantasic, I don't have good mental imagery when it comes to visual stuff. I do dream, and I was reading something about hallucinations and aphantasia, but I've taken mushrooms and LSD and all that stuff and had tons of hallucinations. So, and I also dream. I think I dream, so maybe I'm not fully aphantasic. But when it comes to like, can you picture the sunset? I get zero, nothing, nada. My mom's voice, maybe. I think I'm better with the auditory stuff. But I don't know. He's trying to get us to think, I don't think you need all this mental imagery stuff to be impressed by consciousness. So just look around you.
You have an experience, right? There's no sound in the brain. All there is a chemical reaction.
Same as when you're flapping your gums at me, bro. Like, yes, okay, we get it.
Think of your favorite song. John Lennon, Imagine.
No.
You hear it.
That's your favorite song? What's my favorite song? Rain and Blood by Slayer. That's probably not my favorite song, but it's a good song. I have lots of favorite songs. Bald Heads by Bob Marley. Interesting. Okay, I have lots of favorite songs, but I can hear like no. All right, you guys didn't come here for this. I get it.
There's no sound in the brain. Think of anything. All there is in the brain is a chemical reaction.
Yes, we know.
So that's why we call it the hard problem of consciousness.
No, that's not
We
why.
cannot explain how we experience anything, including our own body. Because our body.
Yeah, but that's not the hard problem. We can't explain dark matter. The can't explain part is not the hard part. It's because the problem seems like the explanation is going to be different. That makes it hard. Okay, I'm going to stop ranting. I swear, spiraling. This is really triggering me for some reason.
It's an experience right now. You're having the experience that you have a body. I have a body. Or your mind. Can't explain it. Now, there is something called the easy problem of consciousness, and that has been solved. The easy problem is that when you have an experience, there's a chemical reaction or an electrochemical reaction to that experience in your brain. So when you're seeing, there's a electrochemical.
But that's not the easy problem. So the easy problems of consciousness are explaining things in terms of structure and function, how you store information, recall information, issue verbal reports, control your behavior, guide your action. All of those sorts of things are the easy problems. Because they're problems about how you form, store, and manipulate information. Doesn't seem like consciousness is obviously involved with that stuff.
Reaction in your occipital cortex. When you're hearing, there's an electrochemical reaction in your auditory cortex, etc. So these electrochemical reactions in the body, they are called the neural correlates of consciousness.
Okay.
NCC. So every experience we have, there's a neural correlate, which you can see on a CAT scan or a brain scan. These days, there's lots of amazing technology that allows you to look at the brain when somebody's having a thought or an emotion or a perceptual experience. These are called neural correlates of consciousness.
We don't know what the neural correlates of consciousness are, or even whether we should be looking for such things. This is still an open question in the field.
Correlates. They're not called neural causes of consciousness.
Yeah.
Because we don't know if these chemical reactions produce consciousness or experience. We don't know. All we know, there's some correspondence. But just for a moment, think about this. Even the neural correlate is an experience, right?
No.
Even the brain is an experience. When you're looking at the brain, that's an experience.
This is what your idealists do. So, yeah, when you're looking at the brain, you're having an experience, sure, but that doesn't mean the brain is an experience. It's a little bit of a leap there, Barkley.
So it all gets very mysterious.
No.
But the fact is, we do not know the origins of consciousness. Just as we do not know how the universe came out of nothing,
It's
we
true.
do
We'll
not
get it.
know the origins of consciousness.
Yeah, so, we got to be all right with not knowing. It's okay not to know. I'm with Socrates on this. The first step towards knowledge is admitting you don't know. I got a problem. I need help. I don't know. This kind of let's insert some confidence into the we don't know. It's a real big put off to me, actually, not into it.
And since yesterday, we've been exploring consciousness in different ways, and we've come to one conclusion that consciousness is not a thing, it's formless. You remember? So, consciousness, like the universe, is made of nothing.
Oh, God, here we go. Formless. Well, yeah, I can see that if you meditate and you're examining, it doesn't seem like it's a thing. Like it doesn't seem like a table or a chair. So I sort of understand where he's coming from there, but okay, it's not made of nothing. Okay, dude.
The universe is made of nothing, and consciousness is made of nothing. Could there be a connection?
No.
That nothing interacting with nothing produces everything.
Wow.
When I say nothing interacting with nothing, I imply two different kinds of nothing. Could they be the same nothing? In other words, nothing interacting with nothing produces everything. And by nothing, just break down the word, no thing.
Yes, no thing.
No thing, that's what nothing means.
It means
No
no
thing
thing.
becomes all things. Okay, so this is where we are today in science. Now let's backtrack and see how human beings have thought about this mystery for ever since they started thinking.
Okay. This is almost okay. This is almost too much for my tender brain. It's almost been an hour of this. Holy shit. Okay, so let's take a break. You tell me whether I should finish this video or not. I mean, I feel like I should because I started it, but it's just, is this serious? Am I an asshole? Is this serious? I want to take these ideas seriously, but is this that? Man, I don't know. Okay, you tell me.